Hello, everyone, and I trust that you're doing great today. Now, today we're looking at the concave lens, and we're going to do this in two parts. One, we're going to look at the general concept of a concave lens, and then we're going to jump into how to draw basic ray diagrams. The first thing we're going to do here is to label this diagram. And so a concave lens is also called a diverging lens. The reason for this is because when parallel rays pass through the concave lens, the refracted rays, they will diverge. In other words, they will spread out from each other. We also have a path through the center of the lens, starting from one thick end to the other thick end, and this path is called the optical axis. The very center of the lens is called the optical center. We also have what we call the principal axis. The principal axis is an imaginary line going through the center of the lens, extending from one 2F to the other 2F on the opposite side. Along the principal axis, we have what we call a focal point. It is also called the principal focus. A point to note, the distance from the optical axis to the focal point is called the focal length. Also, another point to note is that refracted rays will seem to pass through the focal point on the same side as the object. We also have twice that distance, which is called 2F. And 2F is also called the center of curvature. We also have our object, and any ray that comes from the object is called an incident ray. The one that you're seeing on this diagram here is called a parallel incident ray. It is parallel because it's parallel to the principal axis. Also, parallel incident rays, they are the only rays that will refract. And so we have our refracted ray coming from our parallel incident ray. A point to note again is that refracted rays, they will pass through F on the same side as the object. All right, now let's jump into how to draw basic ray diagrams. And this will be the concept for all ray diagrams for concave lens. Now, once you have the object, and the object can be placed at any distance in front of the lens. Now, the first thing to do, though, is to draw a ray coming from the top of the object all the way through the optical center. This ray, it will not be refracted or deviated at all. So it will be a very straight line. The other ray will be our parallel incident ray. And remember what we talk about parallel incident rays. Parallel incident rays, they are the ones that will be refracted. And so coming from this parallel incident ray, we will have a refracting ray. And this ray, again, it must be in a diverging manner, which means it's spreading away from the principal axis. The next point to note, again, is that the refracted ray must pass through F on the same side as the object. So let's put a line that represents that line that is seemingly coming from the refracted ray. Now, where the lines meet, that's where our image will be formed. And so image will be formed where the lines meet. Now, I want you to note that the image itself will be on the same side as the object. It will also be upright. And also, because it's on the same side, then it must be a virtual image. The image will also be diminished or smaller than the object. Again, it will be for all position of object for a concave lens. The only difference is how close the image and the object will be, and also how big the image will be. But in general concept, the image will be smaller than the object. Now we have a very special case, and this one is if the object is at infinity. Now if the object is at infinity, then what we will have is only parallel rays. And so once we have parallel rays, again, they will be refracted in a diverging manner. And these refracted rays will seemingly go through F. So let's draw our lines going through F. Now, since the lines meet at F, then the image will be formed at F. Now, there's something special about this image at F. Again, it will be on the same side as the object, definitely upright. It will be virtual, but the very important thing here, it will be very small. So we generally say it is diminished or smaller, but it will be extremely small, just to make a note of that. All right, so I hope this was a very helpful lesson for you. And I want to thank you for watching this lesson. And I also want to remind you that you need to be a ray of light. So try your very best to always be good to others and be their ray of hope. So thank you for watching again, and I will talk to you soon.